I'm really fascinated by the Google Earth tool that allows you to view a elevation profile between 2 points or a drawn path over the surface of the Earth. What I thought would be interesting is if I mapped out a portion of the Nile River. The Nile River is the longest river in the world. I think in total distance, it's almost 5,000 miles from the source point to where it empties out in the sea. But what I wanted to do was map out this section here that's shown in red so that we can see two bends. We could see the major bend here in the river and then a major bend here. And we've been told all of our lives that water follows the path of least resistance. What we should see when we look at the elevation profile of this line segment is that the highest point elevation should be here and the lowest point elevation should be here. Secondly, after we look at that, I wanted to look at a cross section. If we were to start from this point where this green line is shown and end on this point, shouldn't the river flow in the low points of this cross section? And so first things first, let's look at the Nile River segment. I'm going to switch it to the elevation profile. So here we have the beginning where I started to track it at 1,400 feet above sea level. And sure enough, as we follow the river, the gradual slope is downward. And then there are points where the elevation actually goes up. And what that means is that the water has to reach 1,238 feet above sea level to spill over that geographic limitation and then continue to flow downward. So where we see the upward trends in the feet above sea level is where we see the wider parts of the river. And so this continues to flow and gets wide and narrow based on the elevation and continues to go down. You can see that the Nile River flows from mostly south to north, but at this section here, it's actually flowing somewhat southward because of elevation and geographic limitations. And then we get to this large swell where you can see the river gets very wide at this point. And sure enough, it's because there is a dam that is holding the water in place at this point. And so what we should see when I zoom back out here is a major drop off from this kind of swollen part of the river to the remaining part of the river. So let's see if we can follow the arrow. And sure enough, right here is basically the peak of the dam. And then we see a major drop off immediately after it passes over. And the river continues to flow. So as I mentioned before, I thought it would be interesting to show a cross section of the landscape. Basically, if we were to cut the land in half and look at the half, what would it look like? Here's the elevation cross section, and what we should see is in the lowest parts of this elevation profile, that's where the river should flow. So here where it gets very low, we should see river. And what do we see? That's where the river's flowing. Here's another low point in the cross section, so the river should flow here, and sure enough it does. And here should be another point where the river flows in this low point, and sure enough it does. So all this to say, water has mass, it takes up space, it always takes the shape of its container, but most importantly, water follows the path of least resistance, which means that it is impossible. It is absolutely impossible for us to be living on a spinning globe.